Hello, my name is Tom Watson. I work at IBM. I'm also the co-lead of the Equinox project at Eclipse, and today I'm here to talk to you about enforcing modularity with OSGi. This presentation is not about modularity. I assume we all know what modularity is, and we agree that it is a good thing. If you don't know what modularity is, or you disagree that it is a good thing, then the presentation probably is not for you. This presentation is going to focus on how to use OSGi as a mean for achieving modularity. For everybody familiar with Java, we come to the realization it provides a very nice execution environment that we're able to program our applications against and run them against, and it provides nice APIs that we've all gotten quite used to. But at the core VM level, it doesn't provide any proper isolation and modularity support. And at the core, this is what OSGi is solving and providing a modularity layer. So what OSGi really does is it adds a layer between your application and the VM in order to enforce modularity by limiting type visibility between the different modules that make up your application. So let's review the Java class path. In this example, I have the application is represented by app.jar, and it has a number of other jars that it needs on its class path, including bar and foo.jar, and then the rt.jar represents the classes available from the VM. So in this example, the blue circles really represent public classes within packages that are in these jars, and they're all visible and accessible by your application code. So this isn't really modularity at all. You're just basically seeing every class that's available on the class path, and there's no way to control the visibility between the public types on the class path. So now I'll introduce OSGi into this picture, and I'll start enforcing our modular boundaries. So the boundaries in this case are between the individual jars that are on the class path. OSGi only allows your module or your application to see public types that are in the java.star package. All other types will be denied access. So anything in the app.jar will not be able to see packages from the bar.jar or the foo.jar. You'll notice that even the java.x packages provided by the VM are not visible. Again, only the java.star packages provided by the rt.jar in this case are actually visible to the app.jar. And the reason OSGi does this is because global type visibility makes it very difficult to know the true code dependencies between your modules, and also does not allow you to control access to types that should not be visible to your individual module. So at this point in the presentation, you're probably asking yourself, how can a module be of any use if it can't see anything and no one can see into it? And the answer is probably not very useful. So OSGi does provide ways of controlling what you can and can't access. So first let's talk about how you expose public types to share with others. OSGi allows you to export all public types that are in a particular package. And the way this is done is through the export package header that is contained in the jar manifest. So in this particular example, I show an export package header that is exporting the org-foo p1 and org-foo p2 packages. So by default, your code only has access to the java.star packages. So in almost all cases, you'll need to have a way to ask for more. And the way OSGi does this is packages that you wish to import, you must list in another manifest header import package. So in this particular example, I'm showing org-foo p1 and org-foo p2 as being imported into the app.jar module. So that covers how you declare what you import and export. But at runtime, the framework is actually responsible for resolving module dependencies and then also enforcing the module boundaries. And a module cannot be used until its dependencies are actually satisfied. So at runtime, we resolve an export from foo to an import into app. And then at runtime, the framework enforces these module boundaries. It ensures that only the exported packages are exposed and only the imported packages are actually visible to the module which is importing them. So in this example, the app.jar only has access to those foo packages that it is importing, and it can't have access to any of these other types that were not exported by the foo.jar. So in conclusion, you should keep in mind that when you're dealing with a module system, modules are a design primitive. Just like classes, you really need to think about it when you're designing these, and you need to really think about what you put into a module. You don't want to put too much and make the module too big, but you also need to control what you're going to expose from the module and consider API for others, and then what also to expose to another module. In other words, what you want to import, because you don't always want to have too many dependencies. You would rather make things loosely coupled between your different modules. So OSGi gives you the tools in order to restrict this global type visibility and enforce these module boundaries, and it also provides the strict explicit type visibility rules to give you control back to what you're going to access between the module boundaries.